Variables. In Visual Basic, as in any other programming language, variables store values during a program's execution. A variable has a name and a value. For example, the variable username can have the value Sam, and the variable discount can have the value of 0.10. Username and discount are variable names, and Sam and 0.10 are their values. Sam is a string, and 0.10 is a numeric value. The data type of a variable is specified when the variable is declared, and you should always declare variables before using them. To declare a variable, enter the dim statement, followed by the variable's name, the as keyword, and the variable's type. Now, let's try working with a sample program. Create a new project in Visual Studio 2008 and enter the project name as Variables, and then click OK. Make Form 1 a little smaller and add a button control from the toolbox to it. Set the button's text property to add1 to int number and its name property to btn add. Now then, your form should look like this. Double-click the button control and in its click event, paste this code to it. Run the project. Click the add1 to int number button and you'll see a message box that looks such as this. Now then, let's discuss how this works. The first line defines a new variable called int number. Dim is a keyword. Dim tells Visual Basic 2008 that what follows is a variable definition. The variable name comes next, and that is int number. In this case, the prefix int is short for integer, which represents the data type for this variable. Then a name was chosen for this variable, and in this case the name is number. The next line sets the value of int number. In other words, it stores the value 27 in the variable int number. The next statement simply adds 1 to the variable int number. What this line actually means is, keep the current value of int number, and then add 1 to it. The final line displays a message box with the text value of int number plus 1 equals, and the current value of the int number. Data types. A data type in a programming language is a set of data with values having predefined characteristics. Data type is a data storage format that can contain a specific type or range of values. The .NET framework defines several core data types. Each data type is implemented as a specific class within the system namespace. All the data types implemented in the Visual Basic language are wrappers for the core .NET data types. Now then, this table lists the Visual Basic data types and their .NET equivalents. Literals. The quickest way to include values of a particular data type in your Visual Basic code is to use a literal. Let's consider this command. Now, this call to the msgbox function includes a string literal. String literals always appear within a set of double quotes. Most numeric literals appear with a data type defining character on the end of the literal, but there are other variations. This table lists the different literal values you can include in your code. Constants. Constants are a cross between a literal and a variable. They have a single, never-changing value, just like data literals, but they also have a name that you can use over and over again, just like variables. You can declare constants using the const keyword instead of the dim keyword. Now then, let's work with a sample program. Create a new Windows Form application in Visual Studio 2008 and name it Constants. Add 3 button controls. Arrange the controls such as this. Set the name property of the first button to btnx the second to btny, and the third, you guessed it, to btnz. Change the text property of each to x, y, and z respectively. View the code editor of the form by double-clicking it. At the top of the class definition, add this line of code. Double-click the first button control, and in its click event, paste this line of code. In the second button control, paste this line of code. Likewise, in the third button control, paste this line of code. Now then, run the application by pressing F5. Then click button X, and you'll see the message box as this. Likewise, you'll see the same file name when you click buttons Y and Z. Now, let's see how this application works. A constant is actually a type of value that cannot be changed when the program is running. It is defined as a variable, but you add const to the definition indicating that this variable is constant and cannot change. You'll notice that this has a data type, just like a variable, and you have to give it a value when it's defined, which makes sense because you can't change it later. When you want to use the constant, you refer to it as you would refer to any variable, and we're calling the same constant str file name on all three button controls. Enumerations and comments. Enumerations, one of the core .NET types, allow you to group together named, related integer values as a set. Once bound together, the enumeration can be used like any other data type. You can create variables that are specific instances of an enumeration. You can declare enumeration using the enum keyword. Each enumeration member appears on a separate line, ending with the final closed-end enum line. Now have a look at this code snippet. The declaration line, O1, includes the enum keyword, the name of the enumeration, char type, and the underlying data type, integer. The as data type clause is optional. If you leave it off, the enumeration defaults to integer. Each member of the enumeration, lines O2 through O6, must include at least a member, such as sedan, station wagon, truck, etc. You can optionally assign a numeric value to some or all of the members, as I've done in this sample. Once defined, enumeration members act a lot like integer constants. You can use them anywhere you would normally use a literal or constant. When referencing the members of an enumeration in your code, include both the enumeration name and the member name, such as this. Comments. Comments are parts of a program that are ignored by the Visual Basic 2008 compiler, which means you can write whatever you like in them, be it English, C#, Perl, Fortran, Chinese, you get the picture. What they're supposed to do is help the human developer reading the code understand what each part of the code is supposed to be doing. In Visual Basic 2008, you begin your comments with an apostrophe. Anything on the same line following that apostrophe is your comment. You can also add comments onto a line that already has code, such as this. Methods. A method is a self-contained block of code that does something. Methods are otherwise called procedures, and they are essentially for two reasons. First, they break a program up and make it more understandable. Secondarily, they promote code reusability. Method does not return a value, that is, it is a subroutine, and so it starts with the sub-keyword and ends with the end sub-statement. Anything between these two statements is the code assigned to the method. Let's take a look at how the method is defined with this sample program. Create a new Windows Forms application in Visual Studio 2008 and then name it Methods. Add a button control to the form. In this application, we're going to build a method that's capable of returning a value. Square the radius, multiply it by pi. Double-click the form, and in the code editor window, paste this line of code. Now, double-click the button control, and in its click event, paste this line of code. Finally, run the application by pressing F5. By clicking the button, you'll see the output similar to this. Now let's discuss how this application works. First, we are building a separate method called calculate area from radius. Now, we're doing this by using the private function calculate area from radius block. Now, anything in between private function and end function is the body of the method and will be executed only when the method is called. The by-val radius as double portion defines a parameter for the method. When a parameter is passed by value, as indicated here by the keyword by-val, in the first block of the snippet, we are getting a number that represents the radius of a circle. In the second block of the snippet, we are squaring the radius. In the third block, we are multiplying the squared radius with the math pi, which is a constant defined in .NET that defines the value of pi for us. After the last line, you need to return the result to whatever code called the method. This is done with this statement. Now, let's explore the code snippet placed in the button click event. The first thing to do is define a variable called dbl area that will contain the area of the circle. We set this variable to whatever value calculate area from radius returns. Using parentheses at the end of a method name is how you send the parameters. In this case, we're passing just one parameter, and we're passing the value of 200. After calling the method, we'll wait for the method to finish calculating the area. This area is returned from the method, the return result line defined within calculate area from radius, and stored in the variable dbl area. Then we'll display the final result on the screen using a message box. Operators. You may come across the term operators in many languages, but what's special about operators in VB.NET? Well, we're going to discuss about operators in this lesson. What is an operator? Operator is a symbolic representation to perform a specific task. Operators consist of operands in it. Visual Basic includes a variety of operators that let you manipulate the values of your variables. For example, consider this statement. This statement includes two operators, assignment operators, multiplication. The multiplication operator combines two values, length and width, using multiplication, and the assignment operator stores the product in the square area variable. Without operators, you'd be hard-pressed to calculate an area or any complex formula. In Visual Basic.NET, operators are classified into two types, namely non-assignment operators and assignment operators. Let's discuss them one by one. Non-assignment operators use their operands to produce a result, but they do not cause the operands themselves to be altered in any way. There are two types of non-assignment operators. They are unary and binary. Unary operators work only a single value or operand. Binary operators require two operands, but result in a single processed value. Now let's discuss all the non-assignment operators briefly in our next lesson.